Howdy, 8th grade. Today I want to talk to y'all about mutually exclusive and inclusive events. And what these are a couple things in probability that we haven't learned about yet. So we are going to be learning about some more probability today. And we're going to learn a little bit about what or and mean, because that's kind of different than what you normally hear or use in real life. In probability, or and means kind of different things. So we are going to talk first about the mutually exclusive events and what that means for probability. So I'm going to start by writing down mutually exclusive. And what a mutually exclusive set of events are. So you need two things. And if two things are mutually exclusive, so if two things are ME, that means it is impossible for them both to happen at the same time. So that means they cannot not happen at the same time. So an example of this would be like rolling a die and getting a 3, and rolling a die and getting a 2. I cannot roll one die and get both a 2 and a 3. So what that would look like is if I said the probability of rolling a 2 or a 3 would be the probability of me rolling a 2 or the probability of me rolling a 3. And in probability, this or is actually going to mean plus, which is kind of strange. So this is going to be equals the probability of rolling a 2 plus probability of rolling a 3. And this formula is only true for mutually exclusive events. So this one is only true for mutually exclusive events. So that means the probability of me rolling a 2 or a 3 is going to be equal to the probability of me rolling a 2 with a die. Well, there's 1 2 on the die, there's 6 sides, so that's going to be 1 out of 6. And the probability of me rolling a 3, there's 1 3, there's 6 sides, so that's going to be 1 out of 6. I add these together, I get 2 6ths, which is 1/3. So the probability of rolling a 2 or a 3 is going to be 1/3. I want to do a bit of a harder problem. It's still going to be all about rolling die. So we're going to ask now, if I roll 2 die, what's the probability? So if I roll 2 die, I want to know what is the probability of rolling either a 6 or an 11. So I want to know what the probability of rolling a 6 or an 11 is, and I want to look at all the different possibilities. So the way I'm going to do that is I'm going to make a little grid, and the top column I'm going to call die 1, and the side column I'm going to call die 2. And this is going to let me make a beautiful little grid so we can look at all the different possibilities. My first die can roll a 1, 2, 3, 4, 5, or 6. My second die can roll a 1, 2, 3, 4, 5, or a 6. And I'm going to make a beautiful little grid here. Then we'll start filling in some of these boxes. Here we go. Not what I wanted to do. Should still be red for this. Then I'm going to fill it in with green so it looks a little different. We can see what's going on. So what I'm going to do now is I'm going to fill in all of these. If I roll a 1 with die 2 and a 1 with die 1, I'm going to end up with a 2. A 1 and a 2 is going to give me a 3, and so forth. I can fill all of these in. 3, 4, 5, 6, 7, 8. I want you to see the pattern here. It's not going to be too hard to fill in. This is a hideous 4. Let me fix that, if it lets me. Not going to let me. That's okay. We'll just keep going. If it lets me color anything now, that's definitely not good. There we go. 5, 6, 7, 7, 8, 9, 10, 7, 8, 9, 10, 11, 9, 10, 11, and 12. Awesome. So this does show us some things that we kind of expected here. Like there's only one way to roll a 2, and that's going to be a 1, 1. There's only one way to roll a 12. So because it's impossible to roll both a 6 and an 11 at the same time, I can say that these two events are mutually exclusive, which means the probability of 6 or 11 is going to be equal to the probability of 6 plus the probability of 11. There's a total of 36 possible squares here, and 1, 2, 3, 4, 5 of them are 6s. So my probability of 6 is going to be 5, excuse me, I just said 5, out of 36. And my probability of 11 is going to be 1, 2, 2 out of 36. And because these are mutually exclusive, I can just add them. 5 plus 2 is 7. I'm going to end up with 7 over 36. And that will be my final answer for the probability of 6 or 11. So I know you're thinking, this is too easy. There has to be a catch somewhere, and that catch comes with inclusive events. So I want to talk to y'all a little about inclusive events and what that is going to look like. So an inclusive event is going to be any pair of events that can happen at the same time. So IE's inclusive events can happen at the same time. So this is going to be like I roll 2 die. What's the chances of either the first die being a 1 or the second die being a 1? It's possible for them both to be 1s, so this is going to be an inclusive event, and that's actually what we're going to find. So I'm going to show you guys the formula, then show you guys how it's kind of used. So for the inclusive event case, we are going to find that the probability of A or B is going to be equal to the probability of the first thing plus the probability of the second thing minus the probability of A and B. And this is where I told you that the definition of and means something a little bit different here, because we just said or kind of means multiply when we're doing, or means add when we do probability, and is going to mean multiply. And that seems kind of weird, but you'll see how it works in a second. So my example, like I just said, was if I roll 2 die, what is the probability of one of them, either or, having a 1? So we are going to draw our table real quick. 3, 4, 5, 6. 5, 6. And I'll draw this out, and this will be a real easy table to fill in once we go. The other one, we were asking what the total roll was, so I had to add things up. This one, I don't care what the total roll is. I just care, does it have a 1? So the way I'm going to do that is I'm going to draw a smiley face everywhere I got a 1. So this column here means I got a 1 and a 1, a 1 and a 2, a 1 and a 3, all the way down. And this row is when I got a 2 and a 1, a 3 and a 1, a 4 and a 1, 5 and a 1, or a 6 and a 1. And the rest is just going to be frowny faces because there's no 1s and we wanted a 1. Sad day. This is you playing Dungeons and Dragons, and you wanted a 1 so you could get a critical roll on your dexterity, but instead you've fallen into a bear trap and now you have to gnaw off your leg, which is very sad. Probability, knowledge of it, will make you a much better Dungeons and Dragons player. I know that probably doesn't make any of you want to learn probability anymore, but it's helped me out a lot in the past. So if we're looking at this, we can figure out what the probability of one of these being a 1 is just by counting all of our smiley faces in here. and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those smiley faces. So I know that this right here, my probability of A or B, is going to be set 11 out of 36. But I said that I should be able to find that mathematically, so that should be equal to probability of A plus probability of B minus probability of A and B. And sometimes written like that, that's okay. That's supposed to say and, I just ran out of room. So we'll keep going. And the probability of A is going to be the probability of the first dice being a 1. Because that's what we were saying with A. And the probability of the first die being a 1 is going to be 1 out of 6. So it's going to be 1/6. The probability of B is going to be the probability of the second dice being a 1, which is going to be 1 out of 6. And the probability of A and B is going to be the probability of both happening. And I told you that was multiplication. So that's going to be 1/6 times 1/6, which is 1 out of 36. Another way to think of it would be back up at our grid here. The only square where we have both of them being 1 is this top one. So that's 1 out of 36 of those squares is going to be rolling a 1 and a 1. And that should be subtracted. So if I add these up, 1/6 is going to be 6 out of 36 plus 6 out of 36 minus 1 out of 36. 6 plus 6 is 12, minus 1 is 11 out of 36. So if you don't want to go through and draw the big square, you just say, well, the probability of the first die is going to be 1 out of 6. The probability of the second die is going to be 1 out of 6. And the probability of both of them happening together would be 1 out of 36. So I want to do a quick review here. We have two different formulas, and I want to show you something pretty neat. Because really we only have one formula. And I want to start with the inclusive formula. Let me grab a different color so it's a little more obvious we're doing something new. Pink looks like fun. Inclusive formula is going to be probability of A or B equals probability of A plus the probability of B minus the probability of A and B. And what this term here, just make sure we don't count anything twice. So we subtract what we count twice. We subtract what we counted twice. And what that looks like for our example problem is that if we just added up the probability of rolling a die with the first one and the probability of rolling a die with the second one, we would count these 1, 2, 3, 4, 5, 6. And then we would go down, count the other one, count 1, 2, 3, 4, 5, 6. But we counted this square twice. So we're going to subtract it out, so we only counted it once. And that'll give us the actual probability. So we're subtracting out what we counted twice in that formula. And that's where this comes from. So for mutually exclusive things, my pen's acting weird today, I'm sorry about that. For mutually exclusive things, what we know about the probability of A and B, this will be 0. They can't both happen at the same time. So if that's 0, we get that the probability, wow, that is a beautiful P. I'm just going to go with it. Probability of A or B is going to equal the probability of A plus the probability of B minus, and we said that is going to be 0 just because it's a mutually exclusive event. So that gives us this right here as our formula, which looks nice and pretty. In any case, please work on the practice set before coming in. It shouldn't be too bad, and I will see y'all tomorrow. Toodaloo.